When we provide a path for the capacitor to discharge, the electrons will leave the capacitor and the voltage of the capacitor reduces. It doesn't discharge instantly, but follows an exponential curve. We split this curve into 6 segments, but again we're only interested in the first 5. At point 1, the voltage is always 36.8%. Point 2 will be 13.5%. Point 3 will be 5%. Point 4 will be 1.8%. And point 5 will be 0.7%. For example, if we had a 9-volt battery, a lamp with a resistance of 500 ohms, and a 2000 microfarad capacitor, our time constant would be 500 ohms multiplied by 0.002 farads, which is 1 second. So at the very moment the battery is disconnected, the capacitor will be at 9 volts. And as it's powering the circuit, the lamp will also experience 9 volts. After one time constant, in this case 1 second, the voltage will be 36.8%, which is 3.312 volts. At 2 seconds, it's 1.215 volts. At 3 seconds, it's 0.45 volts. At 4 seconds, it's 0.162 volts. And at 5 seconds, it's 0.063 volts. So the lamp will be illuminated for just under 3 seconds. Obviously, this will become dimmer towards the end of the 3 seconds. Let's say we have a 9-volt battery, a 100 microfarad capacitor, a 10 kiloohm resistor, and a switch which are all in series. The capacitor is fully discharged, and we read 0 volts across the 2 leads. When we close the switch, the capacitor will charge. The voltage will increase until it is the same level as the battery. The voltage increase is not instant. It will have an exponential curve. At first, the voltage increases rapidly, and then it slows down until it reaches the same voltage level as the battery. We split this curve into 6 segments, but we're only interested in the first 5, because at the 5th marker, we're basically at full voltage, so we can ignore anything past this. Each segment represents something called a time constant. Therefore, as we have 5 segments, we have 5 time constants. So it will take 5 time constants to charge the capacitor from 0 to just under 100%. All we need to do is to calculate how long one time constant is, and then we multiply this by 5. To calculate the time constant, we use this formula. Time constant in seconds equals the resistance in ohms multiplied by the capacity in farads. So we convert our resistor to ohms and our capacitor value to farads, and we see that 10,000 ohms multiplied by 0.0001 farads equals 1. So in this example, the time constant is equal to 1 second. Therefore, 5 of these is 5 seconds, meaning it takes 5 seconds for the capacitor to fully charge to 9 volts. If the resistor was just 1000 ohms, the time constant would be 0.1 seconds, so it would take 0.5 seconds to reach 9 volts. If the capacitor was 1000 microfarads, it would take 50 seconds in total. So, as the capacitor size increases, the time taken will also increase. If the resistor value increases, then the time taken also increases. Coming back to our original circuit, we can therefore calculate the voltage level at each time constant. At point 1, the voltage is always 63.2%. Point 2 is 86.5%. Point 3 is 95%. Point 4 is 98.2%. And point 5 is 99.3%. So the voltage will never actually reach 100%. That's also why we stop at just 5 points. So in this example, after 1 second, the capacitor voltage is 5.68 volts. After 2 seconds, it's 7.78 volts. After 3 seconds, it's 8.55 volts. After 4 seconds, it's 8.83 volts. And after 5 seconds, it's 8.94 volts. If you needed a more precise answer, we could also calculate each point like this. Remember, because this is in series, the current of the circuit decreases while the voltage of the capacitor increases. Once at full voltage, no current will flow in the circuit. If the resistor was a lamp, it would therefore instantly reach full brightness when the switch was closed, but then becomes dimmer as the capacitor reaches full voltage. Okay, check out one of the videos on screen now to continue learning electronics engineering, as this is the end of this video. Don't forget to follow us on Facebook, Twitter, Instagram, LinkedIn, and of course the engineeringmindset.com.